Today, we're diving into something pretty mind-blowing from NVIDIA. It's a breakthrough that's giving robots a totally new kind of brain, one that can, in a way, predict the future. And this isn't just some small update, it's a whole new way of thinking about how machines can learn to see and interact with the physical world around us.
So let's just start with this one big question. What if a robot could learn to do things not just by being told what to do, but by predicting what's supposed to happen next? What if it could actually simulate the outcome of an action before it even moves a muscle? It sounds like something straight out of science fiction, but that's the core idea behind this new system.
And that system is called NVIDIA's Cosmos Policy. As we're about to see, this isn't just another small improvement on existing tech. It really is a completely different philosophy for teaching robots how to handle all the messy, complicated stuff in the real world.
Okay, first up, a new brain for robots. Now, to really get what NVIDIA's built here, we need to quickly define a key term. What exactly is a policy?
Simply put, a policy is the robot's brain. That's it. It's the decision-making engine that connects what its cameras see to what its arms and grippers actually do. It's the bridge between seeing something and acting on it. When a robot spots a cup and knows exactly how to go and pick it up, that's its policy in action.
So what's the big deal with Cosmos? What makes it so different? Well, it all comes down to a really fundamental shift in how the AI thinks. It moves from just describing the world to actually predicting it.
Probably the best way to wrap your head around this is with a sports analogy. The old way, using things called vision language models, is kind of like a sports commentator. It can watch the game and describe what should be happening. It can say, the robot should pick up the cup, but it doesn't have the muscle memory to actually play. The new way, the World Foundation model that powers Cosmos, is the player. Because it's been trained on countless hours of video, it has this deep, intuitive grasp of physics. It doesn't just say what to do, it knows how to do it, down to the precise movements.
So how does the model make that huge leap from being a commentator to being the star player? Well, the secret sauce is actually something we see every day: video.
And here it is. This is the core innovation. Instead of having one system for seeing and a totally separate one for doing, Cosmos just smashes them together. It treats a robot's actions, like the command to move its arm just so, as if it were just another frame in a video. The action itself gets encoded in the very same way as all the visual data, making it all one big, seamless sequence.
And what you get is this one, single, incredibly powerful model that learns everything all at once. It predicts the right sequence of moves to make, it predicts what its own cameras are going to see next as a result, and, this is the really cool part, it even predicts how likely that action is to succeed. It's this complete feedback loop, all humming along inside one unified brain.
Okay, so the theory sounds amazing, right? But does it actually work in the real world? Let's check out the numbers and see how this thing really performs.
So what we're looking at here are the results from something called the Libro benchmark. You can think of this as like a super tough obstacle course for robots, testing really complex multi-step tasks. You can see the scores for other top models were already pretty impressive. But then you look at the top, and you see Cosmos Policy setting a brand new state-of-the-art with a stunning success rate
Of 98.5%. I mean, that is almost perfect performance on some seriously difficult challenges. It just blew past every other approach.
But honestly, this next test on the RoboCosa benchmark might be even more mind-blowing. This one measures how well a model can generalize what it learns to a whole bunch of different household tasks. Now look closely at the number of demos needed for training. Most of these other models needed 300 examples to learn what to do. Cosmos Policy not only got the highest success rate, but it did it using only 50 demonstrations. That's just wild.
Let that sink in for a second. 67.1% success, but with 6 times less training data. That is a massive deal. It proves the model isn't just memorizing tasks, it's truly learning and generalizing the underlying principles of physics, which makes it incredibly efficient.
So what's the ultimate takeaway from all this data? It's simple, really. The reason Cosmos is so good and so efficient comes back to its foundation, NVIDIA. By learning the physics of the world from massive amounts of video before it ever even sees a single robot demonstration, it gets this huge head start. It isn't just memorizing tasks, it's understanding how things are supposed to work.
Now, what's really exciting is that NVIDIA isn't keeping this technology locked away in a lab. Nope, they're actively encouraging developers like you to get your hands on it and start building the future. They're hosting an event called the Cosmos Cook-Off. It's an open hackathon for anyone to experiment with these new World Foundation models.
They've put all the code, models, and starter kits up on GitHub and Hugging Face, and they're offering some pretty serious prizes for the most innovative projects.
So, we'll leave you with this one last thought. With a tool this powerful, a robot that can learn by predicting what's going to happen next, what would you teach it to do?